Good afternoon. We've got Dr. Eng here. Today we're going to be working on an application style question. These questions are typically applicable in industry, especially in civil engineering. So I thought it would be useful to have a go at one of these type of questions. So a bar 400 millimeters long with a diameter of 25 millimeters is subjected to a load of 50 kilonewtons. The length increases to 405 millimeters under this load. If the Poisson's ratio for the material is 0.3, calculate the... So for this particular question, using the parameters already given, we're going to be calculating the stress, the strain, the modulus of elasticity, Young modulus, and the change in the outside diameter using the parameters given in the question. So to answer part A, so to calculate the stress, there we know that stress, which can be sigma, which has got a special symbol, stress equals force over area. To calculate the area of in this particular question, it would be an area of a bar so we know it's a round bar as it's got a diameter of 25 millimeters. So the area, to calculate the area, we can do area equals pi d squared over 4. So for this particular question, we have been given a force of 50 kilonewtons. So 50 times 10 to the 3. And then the area would be pi multiplied by the diameter, which in this case would be 25 squared over 4. Once you've then put that into your calculator, you should then get a stress value of 101.87 newton meters. Okay, so when answering this question, please do ensure you get use consistent units, otherwise you'll end up getting the wrong answer. Next, for part B, we're going to be calculating the strain. The formula for strain is change in length over original length So in our question, we can see that the length increases from 400 from the original length, which is 400, and the change in length is 405. The change in length therefore would be 5. And then the original length was 400. So then once you put that into your calculator, you will then get an answer of 0.0125. And to calculate the modulus or elasticity or Young modulus, as known in brief, you simply use this formula. So Young modulus equals stress over strain. This is something that you obviously would have become familiar with in GCSE physics in relation to Hooke's law. So in this case, it would be 101.87, which is the value of stress that we got initially, divided by the strain, which in our case would be 0.0125. And then once you put that into the calculator, you will then get a result of 8.14 giganewtons meters squared. Okay, so just highlight this here. In relation to the strain, 400 millimeters was the original length of the bar. The length increases to 405 mil, and that's a change of 5. This is where we've got this part of the working, and then 400 was the original. And then next we move on to working out the change in the outer diameter. So in order to do part D of the question, we would need to work out the lateral strain, and there's a special formula that you would use for that. Which in our case would be the Poisson's ratio multiplied by the axial strain. So the Poisson's ratio, that's for the symbol which signifies the Poisson's ratio, and then the axial strain, which is subjected to the bar. So in order to calculate the lateral strain, we would do minus 0.3 multiplied by 0.0125. That would then give us an answer of 3.75 times 10 to the minus 3. And then in order to work out the change in the outer diameter, we know that from the theory that we've learned, that the change in diameter over diameter equals negative 3.75 times 10 to the minus 3, which is the lateral strain value that we got from doing that calculation. And in the question, we've obviously been given the diameter of 25. So if so the change in diameter of the bar equals minus 3.75 times 10 to the minus 3 multiplied by 25. And that would then give us a change of minus 0.0938 millimeters. So I do hope that you found this example useful. It's actually quite a an applicable example in industry on what actually happens to a bar when it's subjected to these stresses and strains. So I do hope that you've enjoyed my video. Please do take the time to like, share, and subscribe. I do want to build a community over time, and I do appreciate you taking the time to view my videos. So do have a nice remainder of your day, and I'll see you for the next one.